Hello student, I am Dr. S.N. Munde, Assistant Professor, Department of Mathematics, Sri RLT College of Science, Akola. Dear student, in the previous lecture, we have seen some problems on a mixed saddle point or mixed strategy and problems on without saddle point. Okay, I think we have seen two problems on without saddle point, and I think I think I have given to you one problem for the homework. So I hope you have solved that problem. Okay. So in this lecture we will see another next problem. Okay. So these are the we have seen in previous lecture one two problem, and I think I have given to you one problem this for the homework. Okay. Now we will see the next problem number 4, which is the different as compared to previous problem. Okay. So this is the theoretical problem. Okay. Consider a modified form of the matching bias coin, and consider a modified form of matching bias coin game problem. Okay. The matching player is paid rupees 8 rupees if two coins turn both head, and Rs 1 rupees if the coin turn both tails. Okay, so this is the matching player. So this is the data about the matching player. Okay. Second is the non-matching player. This is the data for a non-matching player. The non-matching player paid Rs 3 rupees when the two coins do not match. Okay. Given that given the choice of being the matching or non-matching player, which would you choose and what would your strategy? Okay, so here we have given the data for matching player and non-matching player. Okay, then we have to find out the which strategy would you would be the select matching player or non-matching player, and what will be the strategy for the matching player or non-matching player. Okay, so this is the given data for the matching player and non-matching player. Okay, so first of all we have to make the payoff matrix. We have to create the payoff matrix. The payoff matrix for the matching player is given by, okay, so the payoff matrix for matching player is given by, this is the matching player. Okay, matching player, and this is the non-matching player. Okay, or you can consider this is the player A and this is the player B. Okay, this is the head tail. Okay, okay, head tail. So what is our data? Matching player is paid rupees 8 rupees if the coin turn both head. Okay, so if head and head, if there is a both uh, the turn of both coin is head, then 8 rupees will paid. Second is, and Rs 1 rupees if the coin turn both tails. If the coin is tail, this is tail and this is tail. Okay, if there is a intersection of head, then there will be the matching player will paid 8 rupees, and if there is a intersection of tail, then we can say that matching player will paid 1 rupees. Okay, this is the matching player data. Okay, so this is 8 and this is 1. If the coin is head, then matching player will paid 8 rupees, and if the if the coin is tail, then matching player will paid 1 rupees. Okay, second step, non-matching player paid Rs 3 rupees when the two coins do not match. Okay, that means head and tail, that is minus 3. That means this is the loss of the non-matching player, and this is the gain of the matching player. So this can be written as minus 3. Okay, non-matching player paid Rs 3 rupees when the two coins do not match, means head tail, and tail head, that is minus 3. This is the loss of the non-matching player. Okay, so we can construct in this way the payoff matrix for matching player and non-matching player. Now we will find out the row minima. Row minima means find out the select the smallest value in each row, that is minus 3, and here is minus 3. Column maxima, that is 8 and that is 1. Okay, so make minimum value in each row star and maximum value in each column plus. Okay, so if you observe from this given payoff matrix, the given payoff matrix is without saddle point. Okay, that means we can say that there is no combined term star and plus. Okay, so therefore we can say that the given payoff matrix is without saddle point. That means we can say that the given payoff matrix is without saddle point. The optimum strategy will be mixed strategy. Okay, so therefore we will find out the mixed strategy for player for matching player and non-matching player. Okay, so that the mixed strategies for matching player and non-matching player are determined by P1 is given as, we can write the formula, that is P1 P2 and Q1 Q2 for now matching player P1 P2 and non-matching player Q1 Q2. Okay, so this is the for matching player. So P1 is given as formula A22 minus A21 A11 plus A12 minus A12 plus A21. So putting the values from given payoff matrix, A11 means 8, A12 is minus 3, A21 is minus 3, A22 is 1. So putting the all values from this payoff matrix, we will get P1 is 4 upon 15. Now we will find out P2. P2 means by using conditions P1 plus P2. So this P2 can be written as 1 minus P1. So putting the values of P1, we will get 11 by 15. So which must satisfy this condition. If you put the values of P1 plus P1 and P2 in this equation, so this must be equal to the 1. Now we will find out the optimum strategy for non-matching player. And it is given as Q1 equal to A22 minus A12 divided by A11 plus A22 minus A12 plus A21. A12 plus A21. So putting these values from the given payoff matrix and calculate, we will get Q1 is 4 upon 15. So we will find out the Q2. Q2 is given as 1 minus Q1 by using the condition, that is Q1 plus Q2. So Q2 will be found to be 11 by 15. Okay, so this is the mixed strategy for player non-matching player. Therefore the expected value of the game is given as V equal to A11 A22 minus A12 A21 divided by A11 plus A22 minus A12 plus A21. So this is the formula for the value of the game. Putting all the values from the given payoff matrix and solve, so you will get V equal to minus 1 upon 15. Okay, so now we will find out the optimum strategies for a matching player. The optimum strategy for a matching player is P1 and P2. P1 is 4 upon 15, P2 is 11 upon 15. So this is the optimum strategy for matching player. And the optimum strategy for non-matching player is 4 upon 5, that is Q1 Q2. Q1 is 4 upon 5 and Q2 is 11 by 5. So this is the non-matching player. And the value of the game V is minus 1 upon 15. Okay, so these are the optimum strategy for matching player as well as non-matching player. Okay, so here clearly we can say that we can we would like to choose the non-matching player. Okay, because the optimum strategy for both player are same. Okay, so we can choose optimum strategy. We can choose the non-matching player. Second, another example is the given payoff matrix is 6 minus 3 minus 3 0. Okay, So we can similar way we can solve this problem. Okay, so find out the row minima and column maxima, minimax and maximin. Okay, so this is the given pair matrix. Here row minima means select smallest value in each row, that is -3, and this is -3. Maximin means largest value in row minima, that is -3, that is -3. Column maxima means select largest value in each column, that is 6, and this is 0. Minimax means smallest value in column maxima, that is it is denoted by upper V bar. If you see, clearly the given payoff matrix does not possess any saddle point. The player use mixed strategies. Therefore, the optimum mixed strategy is given as P1 is A22 minus A12, A11 A22 minus A21 plus A12. Okay, so by using this formula, putting all the values from the given payoff matrix and solve, we will get P1 is 1 by 4. Okay. Now by using the conditions P1 plus P2 equal to, this is not 0, this is 1, this is 1. So P2 can be obtained as 1 minus P1. So that is P2 is 3 by 4. Similarly, we can find out Q1 and Q2. Q1 is given by this formula. Okay, optimum strategy for player B. So this is the formula, putting the values from the given payoff matrix and solving, we will get Q1 is 1 by 4. Then by using conditions, that is Q1 plus Q2, so we can find out Q2 is 1 minus Q1. Putting the values of Q1, you will get the Q2 is 3 by 4. Okay. Then finally, we will find out the expected value of the game, or value of the game V is given by this formula A11 into A22 minus A21 into A12 divided by A11 plus A22 minus A21 plus A12. Okay, so putting these values from the given payoff matrix and calculate, so you will get the value of the game V is, that is minus 3 upon 4. So this is the value of the game. Okay, now therefore the optimum strategy for player A is, P1 P2, that is 1 upon 4 and 3 upon 4, and optimum strategy for player B is B1 B2 Q1 Q2, that is 1 upon 4 3 upon 4, and the value of the game V is, that is minus 3 upon 4. Okay, so this is the all about of the how to solve the given 2 by 2 payoff matrix without saddle point. Okay, so if there is a question in examination, solve the given payoff matrix 2 by 2 payoff matrix, so you can use this method. That if there is a if there is does not exist any saddle point, then you can solve that problem 2 by 2 payoff matrix by using this method. Okay, so dear student, we have completed 5 problems on a without saddle point. That means we have completed 5 problems on a mixed strategy. So in next lecture we will see another method, that is dominance property, problems on a dominance property. So in next lecture we will see some problems on a dominance property.